Good afternoon, everyone. I choose the absolute towers as my case to do this parametric design. In the beginning, I'd like to introduce this architecture from Mad Architects. The design intent for this skyscraper is not solely on height. The design features a continuous balcony that surrounds the whole building, eliminating the vertical barriers traditionally used in high-rise architecture. The entire building rotates by different degrees at different levels, corresponding with the surrounding scenery. So for each residential unit, it will get a 360-degree views of the city scenery. And after the analysis of the absolute towers, I decided to use ellipses as the basic shape of my as the basic shape of the skyscraper. So first of all, I generated an ellipse. So you can see this ellipse in the view. And because the skyscraper has 56 floors, so I use a series to move this ellipse at an interval of 4 meters. Then I need to rotate. This 56 curves to get the twisting shape of the building. As you can see, this green line. You can see this is the basic shape of the building. And the second step would be building 56 floors according to these curves. Planar node is to make the curves into surfaces, then extrude them so I can get floors. The roof is slightly different. It is bigger than the common floors, so I need to get the last floor curve. Actually, this is the roof and this is the last floor curve. And then I move it upwards and offset it outward, and then extrude it. The roof is finished. We can see that there is a glass handrail on each floor. So I pull back the floor curve a little bit, extrude them. So after having these handrails, I need to attach some small railings on it. I used the horizontal frames node. You can see this green square. They are the location of each railing on each floor, and the circle node. And I extrude this circle. And then I can get these railings on glass handrail. Also the same way to do the columns beneath the roof. They are the same way. And about the envelope, I simply divide each curve into 38 parts, and I use an interpolate node to connect these divided points, and then I extrude them. So you can see the envelope is finished. And then the easiest part would be creating the core tube. Just array and extrude 55 angles. So I can get the core tube inside of the building. Then it comes to the bearing walls inside the envelope. The logic would be generate several rays from the core pointing outward. And you can see the several rays generating from the center of the core and pointing outward. And then I use this curve and line node to get the intersection points of this rays and the curve of floor. And then I extract these points. And actually, the points are on both side. You can see the left side, the right side, and then I use a line to connect them and extrude this line. So now I can get this piece of bearing wall. Also, the same way to do another piece of bearing wall. They are perpendicular to each other. So now the next step would be creating another kind of skin. You can see in this picture, the white area. So now I try to create this surface. They are not the regular surfaces. You can see their shape are not symmetrical. So I use several steps to extract the start points of the surface and also the end points, the second points, and the pinout points, and the points between them. So I use an interpolate curve to connect these points. Then I loft this curve so it becomes another skin of the building. There are two skins of the building, so the same way to do the other part of the skin. So now the basic form and structure of absolute towers are finished, and I want to simulate the stress condition of the envelope when it is blown by wind. So I use Kangaroo to simulate this process, and then I input the wind force, the spring force, and the gravity into the force objects. And I set several anchor points. So after setting these anchor points along the edge of each mesh, I can turn on the toggle. So the final effect would be like this. And I can change the gravity and the direction and magnitude of the wind. Then the effect would change together with my modification. This is my parametric design of the absolute tower. And I can show you the analysis part. I use Zebra to analyze the smoothness of the mesh. And then I use Planar to test if the curve is planar, and use Cavalier graph to draw the curvature of the curve. And I can also get its area by using this area node. And also I can get its edge point of each mesh, and also the edge curve for each mesh. So this is the basic of my parametric design. Thank you.